Okay, so I solve this and you solve this. All right, so solution. So we are going to be using the arrow method subsequently. I believe you have understood the formula method. All right, so the question says a radioactive sample initially contains N atoms. So the question um, did not specify the actual amount. So you start with N, all right? Then after three half lives, so which is equivalent to three arrows. Okay, so I'm going to draw three arrows or three half lives. The first half life, okay, this will be N over 2. After the second half life, this will be N over 4. After the third, this will be N over 8. So I'm to stop here. All right, so the number of atoms that have disintegrated is what? So I need you to know that anywhere you stop, okay, that's the number or the fraction, okay, the fraction of the whole that is remaining. This word remaining is very, very important. Remaining, okay. So if they had asked us to find the number of atoms remaining, it's okay, would have just said the answer is N over 8. But because they said the fraction or the number of atoms that have disintegrated, so it will be the total, which is N minus N over 8. And if you do this well, of course, you find the LCM, which is 8. 1 here is 8. 8 times N is 8N minus, this is 1. 1 times N will give you N. So this will give you 7N over 8, which is the correct answer. D. Okay. Number 14. The half-life of a radioactive substance is 2 seconds. 2 seconds. So half-life is 2 seconds. Calculate the decay constant. Okay, so I already know that the relationship between half-life and decay constant is this. Ln 2 all over decay constant. So natural log of 2 or ln 2 is the same as 0.693. Of course, this, right? So if I'm to find the decay constant, which is this, just make it the subject of the formula. This will be 0.693 over half-life. This will give us 0.693 over 2. And if we punch this, we are going to get 0.693 divided by 2. Okay, so this will give us 0.3465. But what will be the unit per second? Remember, whatever the half-life is, the unit of the lambda, which is the decay constant, will be P of the unit of whatever the half-life is. Is that okay? All right, so it's your turn now. So solve this one. All right, so a radioactive element decays to 1/8 of its original quantity in 9 seconds. 1/8. So I can start with 1. Remember, this will be 1 all over 2, 1 over 4, 1 over 8. So once I get to 1/8, I will stop. All right, and then they said you get to 1 over 8 in 9 seconds. That means each half-life here will be 9 divided by 3. So we have 3 half-lives or 3 arrows. So each half-life will be 9 divided by 3, which will give us 3. All right, 3 seconds. So, but the question says we should calculate the decay constant, not the half-life. So again, decay constant is 0.693 divided by the half-life, which is this. Half-life is 3. So this will give us what? This will give us 0.231. 0.231. Again, the unit will be what? Per second.